All right, so the 2-2 part 1 takeaway. Like I said, this is closer maybe to an English lesson than maybe a math lesson, but it ties in the logic and reason, which is definitely a math standard. So logic and reasoning. It helps you, like I said earlier, it helps you in bringing out some logic into a conversation, adding some reason to an argument. Helps you in those types of communication areas. But also there's a lot of logic and reason in math, which is why we put it in here. So we're going to start with conditional statements. So if-then statements, they're called conditional statements or conditionals. The if part is what we call the hypothesis, symbolized with a P there. The Q is the conclusion. So here's your example. If it's raining outside, then you need an umbrella. If it's raining outside, then you need an umbrella. So the hypothesis is it's raining outside. The conclusion is you need an umbrella. So here's the situation. It's raining outside. So what does that mean? You need an umbrella. There you go. So the hypothesis leads to the conclusion. If the hypothesis is satisfied, then the conclusion is satisfied. It doesn't always. It's not always true if it's the other way around. Okay. What if I have this conditional statement and I say, "Well, I got my umbrella, guys." What does that mean? Doesn't really mean much, right? Maybe I just have an umbrella to shade the sun or something. Okay. So not all conditional statements are what we call biconditional. They're not all reversible. Some are. We'll also talk about truth values. Truth values, just true or false. They're true or false questions. If it's false, you would need to provide a counter example. So write the sentence down. And I am asking you a true or false question, but that doesn't mean just pick one and yell it out. It means think about it, and then come up with a true or false answer. Did you think about it? If I live in Brookville, then I live in Franklin County. So if it's true, great. If it's false, that must mean you thought of an example that would make it false. You thought of a counter example. If you live in Brookville, okay, then you live in the county of Franklin County. Mm-hmm. What do you guys think? Is this true or false? You think it's true? In all cases, in all situations? Anybody think it's false?
I thought it was at first.
Well, if you think it's false, that must mean you're thinking of an example that would make it false. Like if I came in and I said, "Hi, I'm Joe Davidson. I'm from Brookville." You'd be like, "Oh, he's from Franklin County, Indiana." Would that be true?
Mm-hmm.
I wonder if there's any other Brookvilles in America.
There is.
There is, isn't there?
There's a.
So, if I came in and I was like, "Hi, I'm from Brookville," you'd be like, "Oh, so you live in Franklin County, Indiana?" I could be like, "Nah, Brookville, Ohio. Brookville, Ohio." Right? So that would make this statement false, right? So if I live in Brookville, then I live in Franklin County, is not necessarily true. Because you could be talking about Brookville, Ohio. So you have to be careful. I don't know what county Brookville, Ohio is in, but I'm pretty positive it's not Franklin County, Ohio. That'd be weird. All right, try the next two on your own. A little more math related. But we can make true or false statements in math just like we would in any other situation. If the two-digit number ends in a 0 or 5, then it is divisible by 5. So if that's true, great. If it's false, that means you must have thought of a counterexample. So in your head, you're probably trying to list some of those numbers that end in a 0 or 5. 5, 10, 15, 20, 25, 30. Are you finding any of them that aren't divisible by 5? You think this conditional is true? I'm seeing some head nods, yes. Yeah, that one's true. The next one, if 2x plus 5 equals 13, then 2x must equal 8. If you manipulated that first equation, 2x plus 5 equals 13, tried to solve it, what would your next step look like? Would it be 2x equals 8? You think that one's true? It is. So we're going to be writing conditionals, identifying the hypothesis, which is the if part, identifying the conclusion, which is the then part, the Q, determining truth values, true or false, and if it's false, give a counterexample. All right, assignments on the board. Page 99, 1 to 28 all. Let's see how much of this we can get done. So again, this assignment is closer to like an English assignment. So if I were you, I would put this on a Google Doc. I would type it out. I feel like I can type all day, but writing all day, I don't know, that doesn't sound fun to me. So the first one has multiple steps. What are the hypothesis and the conclusion of the following statement? Write it as a conditional. It would be helpful to write it as a conditional first, a if-then statement. Then it would be easier to identify the if and identify the then part, okay? So when you're doing these if-then statements, sometimes we miss like the pronoun. And it's a little clunky trying to put it together. So when you're trying to start with an if, add like a pronoun to it. So like if you, if he, if she, if it, if you are, if it is. So in this case, residents of Key West live in Florida. Okay, if they, go ahead, if they what?
Are a resident of Key West, they live in Florida.
Then they live in Florida. If they are residents of Key West, then they live in Florida. That would be a good conditional statement there. Let's see, I probably put something similar to that. Yeah, I said if you live in Key West, then you live in Florida. Now, it's not asking you to determine the truth value of that. It's not a true or false question. It wants you to write it as conditional, and then we can identify the P and the Q, the hypothesis and the conclusion.
Write down what he put in black. What he, sorry, I can't hear.
Good, got it? So now we identify the hypothesis, which is just the if part. I don't need to include the if when I identify it. It comes right after the if. So in this case, it's the live in Florida, or sorry, live in Key West. And the conclusion is live in Florida. So the reason we want to be able to identify those is in the later sections, we're going to be flipping these around, trying to reverse them, see if they still are true or false. We're going to start to negate them, which means to add the word not. So it would be like, if you do not live in Key West, then you do not live in Florida, that sort of thing. So it helps to kind of build a system here using some symbols. Number 2, your classmate rewrote the statement, "You jog every Sunday," as the following conditional. What is your classmate's error? Correct it. So it's a mistake here. He says, if you jog, then it is Sunday. He said that's conditional for the sentence, you jog every Sunday. What's wrong with it? How would you correct it?
If it's Sunday, then you jog.
Yeah, it's the wrong way around, right? So the sentence, you jog every Sunday, means that if it is Sunday, then you jog. When you say, if you jog, then it is Sunday, that's the error that your classmate made. He said, if you jog, then it is Sunday. That means you only jog on Sunday. It means if you're jogging, if you're out there jogging around, then it must be Sunday. That's what that means. But that's not what the sentence says. Thank you. That's not what the sentence says. The sentence says you jog every Sunday. Does it say anything about Monday? Could you jog Monday? Sure. You could jog Tuesday. Jog any day of the week. So the conditional we want is that if it is Sunday, so if that condition, if that hypothesis is satisfied, then you jog. So you want to turn that around. So again, for number 2, it is if it is Sunday, then you jog. All right, any questions or repeats there? Number 3, if a figure is a rectangle, then it has 4 sides. We're just identifying the P and Q, the hypothesis, and the conclusion. So again, don't overthink this too much. What is the hypothesis here? Somebody raise your hand and tell me. A figure is a rectangle. The conclusion then? Anybody? It has 4 sides. Feel free to abbreviate when you can. Why don't you try the next 2 on your own? Try the next 2 on your own. I think you should be able to identify the P and Q there. Any questions so far? All right, I'm going to jump in then on number 6. Again, on number 6, adding that pronoun, adding that if it or if he, if she, if you, if you are, adding that pronoun kind of helps you structure these conditional statements. So the sentence is, Hank Aaron broke Babe Ruth's home run record. And we need to write that as an if-then conditional statement. Anybody want to try it? Go ahead, Misha. If
Hank Aaron broke Babe Ruth.
you missed a pronoun there, didn't you? Straight to Hank Aaron, but that's when it kind of gets funky. If he, go ahead.
Broke Babe Ruth's record.
Then?
Then he's a champion.
Oh, we missed Hank Aaron. Nice try, though. You're getting there. Anybody else want to try? if he is, let's go there. If he is, yes, if he is Hank Aaron, then yes, good. If he is Hank Aaron, or if you are Hank Aaron, then you broke Babe Ruth's home run record. If he is Hank Aaron, comma, then he broke Babe Ruth's home run record. Kind of hard to see there. Again, it says, if he is Hank Aaron, then he broke Babe Ruth's home run record. Number 7, again, adding it to number 7 kind of helps. If it is 3x minus 7 equals 14, then it is 3x equals 21. So if 3x minus 7 equals 14, then 3x equals 21. Don't really even need the pronoun, but it helps a lot of times. Any questions on 7? You got it? Number 8, Thanksgiving in the U.S. falls on the 4th Sunday of November. 4th Sunday of November. So if it is yeah, you guys kind of teamed up there. If it is the 4th Thursday of November, then it is Thanksgiving in the U.S. This is one of those that can be reversed. If you said, if it is Thanksgiving in the U.S., then it is the 4th Thursday of November. It can be reversed, meaning it's a biconditional. We'll talk about that in the next section. It's a biconditional. It can be reversed. We consider that a good definition for Thanksgiving, or at least when Thanksgiving is. It's a good definition for when Thanksgiving is. Can you repeat on number 8? Did you get it? Sorry, I'm not writing all these down. Yep. So looking at number 9 now. If it is, then it is. Or maybe then it shows, I guess. Got it, Spence?
Maybe.
Try it.
If a conjecture is false, then it is a counterexample.
There you go. If a conjecture is false, then there exists a counterexample. Okay. If a conjecture is false, then a counterexample is shown. This one, I think, would be reversible too. Let's try it. If it is a counterexample, then it shows that a conjecture is false. That would work. Number 10, a point in the first quadrant has two positive coordinates. If it is, then it is. You got it?
If there are two positive coordinates, then they are in the first quadrant.
Then it is a point in the first quadrant. If it has two positive coordinates, then it is a point in the first quadrant. That one seems reversible too, right? You said it the other way. If it is a point in the first quadrant, then it has two positive coordinates. Ten. If it is a point in the first quadrant, then it has two positive coordinates. Or you could say it the other way around. If it has two positive coordinates, then it's a point in the first quadrant. All right, number 11, write a conditional statement for each Venn diagram. So on this part, you start out small. The hypothesis is going to be the smaller circle, the smaller set. And then the conclusion is going to be the bigger set. So if it is blue, then it is a color. It would make sense that way. You wouldn't say if it is color, then it is blue. Okay, that doesn't make sense. There's other colors than blue. But if it is blue, then it is a color. You start off with a smaller subset or the more specific subset. And the conclusion then is that it fits into the larger circle, the larger set. Same idea for 12 and 13. If it is a whole number, then it is an integer. You're just using that it is a lot of times. If it is wheat, then it is grain. Ready for 14? Counterexamples? Okay. Determine if the conditional is true or false. So we're determining truth value. If it's false, find a counterexample. If a polygon has 8 sides, then is an octagon. What do you think? True or false? Octagon, 8 sides. Yeah, that's true. Yep. 15. If you live in a country that borders the United States, then you live in Canada. What do you think?
False.
Why? Because there's Mexico, right? Yeah. If you live in a country that borders the United States, then you live in Canada. Well, what if you live in Mexico? Then you also border the United States, right? So that one's false. Mexico. 16, you play a sport with a ball and a bat, then you play baseball. Why? Softball. Or maybe cricket. I don't know. I don't think they call it a ball and a bat. They have like, I don't know. I would call them like kind of funny words. They have funny words for their, I'm trying to think what they are. But I don't think it's ball and bat. A paddle? Okay, that's not that crazy. But the ball is called like a, I don't know. We're going to Google it. If I would have said that, you'd have thought I made that up. The ball is called a kookaburra. I told you it was something weird, kind of funny. So you got to take your paddle and kind of smack that kookaburra. 17, if an angle measures 80, then is acute.
True.
Measures 80, then is acute. Yeah, that one wouldn't work the other way around, though, right? If it's acute, then it measures 80. But as it is true. '18, we are writing 18 as a conditional and if-then statement. The quote is, "We're half the people. We should be half the Congress." So if we are, then we should be. What do you think? Huh?
If we were half the people.
Yep. If we're half the people, then we should be half the Congress. Calling for more women in the office. More congresswomen. Yep. 19 is where we'll stop. If anyone has never made a mistake, anyone who has never made a mistake has never tried anything new. If you've never made a mistake, then you've never tried anything new. You got it. I think that one works backwards too. If you've never tried anything new, and you've never made a mistake, maybe that works. Maybe it doesn't work backwards. Because you could be doing something like that you always do, but you still make a mistake at it. So that one probably doesn't work backwards. All right, so you have 10 more of them to 28 to do on your own. I'll add that picture here for you guys who want to do it from the video. Whoops. All right, here's the rest of them. So if you open up this video, you can find the rest of them, or it's on Canvas. All right, if you have any questions, let me know.